What is the smallest, simplest thing that can be considered alive? You might think of a bacterium, or maybe even a virus, but the truth is, we have no idea. Science hasn't yet found a definitive answer to what the absolute minimum requirements for life are. It's one of the biggest, most fundamental questions out there, and it pushes the boundaries of biology, chemistry, and even philosophy. When we look at life on Earth, everything, from the smallest microbe to the largest blue whale, is incredibly complex. Every living cell is a bustling city of molecules, with DNA as its master blueprint, proteins as its workers, and a cell membrane as its city walls. But is all of this truly necessary? Is there a simpler way to be alive? Let's start with the basics. We often define life by a set of characteristics, things like growth, reproduction, metabolism, and responding to the environment. But even these definitions get blurry at the edges. A crystal can grow, a fire can spread and consume fuel, and some complex chemical reactions can appear to respond to their Are they alive? Most of us would say no. So, what's the secret ingredient they're missing? A big part of the puzzle is organization. Life as we know it is cellular. But is a cell the smallest possible unit of life? Could life exist as something more stripped down? Perhaps just a self-replicating molecule? A kind of naked gene, floating in a primordial soup? Some scientists theorize that this is how life might have started on Earth, with simple RNA molecules that could both store information like DNA and act as an enzyme to build things. This is the RNA world hypothesis. But even then, where do you draw the line? At what point does a complex chemical reaction cross over into being a living thing? We don't have that line clearly drawn. Then there's the DNA question. Every organism on this planet uses DNA, and its cousin RNA, to store its genetic information. It's the universal code for life on Earth. But does it have to be this way? Is DNA the only molecule in the universe capable of doing this job? It's a bit like asking if all computers have to use silicon chips. On Earth, the answer is pretty much yes. But somewhere else, could there be a different kind of genetic material? Scientists have experimented with creating synthetic alternatives to DNA in the lab, called xNAs, which can also store and transmit genetic information. This proves that other molecular systems are possible, at least in principle. It suggests that life elsewhere in the universe might not be DNA-based at all. And that brings us to the most mind-bending question of all, the chemistry of life. All life on Earth is carbon-based and uses water as a solvent. Carbon is fantastic at forming long, complex chains, and water is an amazing solvent that allows all the necessary chemical reactions to happen. But are they the only options? This is what astrobiologists call chemical chauvinism, the assumption that life everywhere must be like us. What about silicon-based life? Silicon is right below carbon on the periodic table, and it can also form 4 bonds, creating complex molecules. You've seen silicon-based life in science fiction, like the Horta from Star Trek. In reality, silicon chemistry is a bit more rigid and less versatile than carbon's, and it's oxide. Silicon dioxide, basically sand as a solid, not a gas like carbon dioxide. That would make breathing pretty difficult. But under very different conditions, say, on a planet much hotter or colder than Earth, with a different atmosphere, could silicon-based life find a way? And what about the solvent? What if a planet is too cold for liquid water? Could life exist in oceans of liquid methane or ammonia, like those found on Saturn's moon, Titan? The chemistry would be completely alien to us. The cell membranes would have to be different. The proteins would have to be different. Everything would be different. It would be life, but not as we know it. We're only just beginning to explore these possibilities in labs and through computer simulations. So, the next time you look up at the night sky, remember this. We're still trying to figure out the most basic rules of the game of life. We don't know how simple it can be, if it has to use DNA, or if it even has to be made of the same stuff we are. The search for the minimum requirements for life isn't just about understanding our own origins. It's about opening our minds to the countless, unimaginable forms that life could take across the cosmos. It's a huge, humbling mystery, and we're just getting started. Thanks for watching. If you enjoyed this journey into the unknown, be sure to like this video, and subscribe for more deep dives into the biggest questions in science. See you next time.